times 1 over x equals 1. X times 1 over x and times y is y. Can in braiding do braiding versus times inverse braiding times another braid and convert to another?
I'm not so sure that I understood the questions. That's.
So you can undo a braid by putting the inverse of the braid at the end of it.
Yes.
So essentially, because you mentioned that
ordered.
Your theory cannot convert the braid, whatever braid.
Okay, so I think that the issue is that braids in the braid group, when you multiply two braids, it's not commutative. So one braid times another braid is different than that braid first and that braid after. So 5 times 7 or 7 5 times, it's the same. But when you talk about matrices, multiplication of matrices is not commutative, and braids is not a commutative group. Fantastic. I should have mentioned it. You don't have to ask questions, and if you want to ask questions, but you can always feel very comfortable. We are not in a lecture, we are in a presentation. You can ask in the middle, you can ask the speakers later. You have to come up at the end that you feel that you are satisfied. So feel free. I don't.
I'll ask you a philosophical question.
Yes.
So the golden section.
Yes.
Relates to the human body.
Yes.
Do you think that we are looking at the human body and we try to identify other races that look like the same, and therefore we're calling them those beautiful races? Like it's more like
It's in all races. In all races, you have this golden section in the body.
right, but then when we go to a room, do we burn our brain because the body is this racial, that room?
This is a very interesting question. I didn't think about it. When you are in a good room, you feel well. You know that it's nice. If you look at a good, you know it's good. Is it connected? Could be. This is something really to talk to philosophers, philosophy of art, art historians. Because Leonardo was the only one that they looked as a pantheon, so you know it. I mean, that's very old, and he suddenly looks at bodies. Maybe this is the case, very much. In New York, you can see houses, very small houses. The living room is like a corridor, very, very narrow, because there's no windows. So very, very narrow, and they say this is okay, but one can never sell this apartment. This is something built in. We don't know to explain it, but we understand it. It can be wide, but if it's very, very long, you still have the bad feeling. Let's say that it's 20 feet wide, but if it's 100 feet long, you won't have a good feeling in this room.
You may put the door at the right distance.
You have to cut it. You have to cut it to 2 rooms, then it will be okay. Yes, please.
So, I'm curious about this. In the amount of art and other art as well, we can see that whole perception quite common in a lot of amazing work that we see. But I'm curious if you're aware of was the existence of the golden section purely the motive because it looks correct or the artist perceived it to be correct, or was it derived from a mathematical principle?
This relates to the question of the din that I asked before. Maybe it's a reflection of our body. I cannot tell you, but it's so fundamental that we feel comfortable when something has the golden section proportion, that something in our brain with the years. You know, everything is an evolution. So maybe this answers your question. Maybe the people that felt nice with it survived more because they knew where to go, or they feel better. I don't know how it developed. Well, I do now computational neuroscience, but I do more the mathematical side, but the questions are coming from biologists, from psychologists, from different people. One project that I do now is the concept of the number in the brain. Is there a concept of a number in the brain? I mean, if I see the number 3 and I hear 3 and I see 3 circles, everything is 3, and you get fires where the neurons are firing in the brain when that. So it will fire with the vision. If you hear 3, it will fire where audio. But will it also fire in some one place that is 3? So to see 3 is here and here. To hear 3 is here and here. And to look at 3 here. So the concept of a number developed, I'm sure developed with the years, but the question that we ask nowadays about what's happening in the brain are so basic that it will take time before we try to see. But this is extremely interesting and challenging. Yes, please. Yeah. I didn't say that we see it in braids, even though some of the braids that I constructed for crypto system had in that they had a golden sanction. I just did it as appendix because we talked about Leonardo, and you cannot talk about Leonardo without showing his human body. So that's why it's I mentioned it, but that's a good question. It means the audience is watching me. Yes, you wanted.
Make a comment on this normal ratio.
Yes.
So before Leonardo was the Fibonacci.
Yes.
And the Fibonacci sequence that also modeled by the spiral.
Yes.
But the ratio of the successive parts in the Fibonacci.
Yeah.
You know that?
Yes.
So what does it convert?
Okay, so maybe one afternoon we'll take a tour and you'll show us all the flowers that looks like Fibonacci spiral. That's true. But I didn't see anything about human body before Leonardo, but that could be, I know. I'm just curious. I'm not an art historian, and Levine died, so my... Yes, please.
Can I offer a possible suggestion to the connection between braids and the cold image?
Fantastic. Go ahead.
When you create a braid, you probably don't want to have lots of really little strands and to be really long. You would probably want the thickness and everything else to be some kind of ratio. So I think we probably do this naturally when you're
Yeah.
something in braiding, that you'll probably section the hair into a good number of pieces so that you're getting that ratio, and you're probably doing it maybe without thinking about it, looking for beauty.
You are right. You are right. So naturally, as I said, when I chose something, I did it. Moshe Cohen was a postdoc in my university in Israel, so we talked a lot. Yes, please, go ahead.
There are, even beyond the social science stuff, I study knots, like the mathematics of knot theory. And one question that I don't really study is about physical knots and what like the thickness of the rope would mean about how much it's allowed to bend, and all of these really difficult questions that have all these applications in hard sciences as well. So I love your proposal. I think there's so much you could do with that.
Fantastic. If there are no more questions,